Good afternoon, everyone. I trust you are all well and that you have managed to do lesson 1 and completed it. So today we are moving on to the Axioms of Probability, which is going to be our second section on this whole topic of prop. Then, as we all know that chance is a slippery concept, we all know that some random events are more likely to occur than others. But the question is, how do we quantify such differences? How do you work out the probability of, say, rolling a 6 on a die? And what does it even mean to say that the probability is 1/6, right? So when we do have all those things being said and all those questions being raised, you will note that the greatest mathematician of all times, Kolmogorov, in 1933, he's the one who came up with these conditions, if I can call them, the axioms of probability, because it was just trying to avoid some tricky questions that we always get whenever we are trying to define probability as an event. So instead of it or him getting deeper into the definition, these are the axioms that he gave us. So tackling through and going over to today's lesson, you will note that we are just going to explain the 5 axioms of probability. Whilst explaining them, I'll also touch on the experimental probability problem that was given in lesson 1. So I'm making the assumption that you try to work it out on your own, so that as we're going through this lesson today, you are just ticking and correcting yourselves wherever you could have done an error. But otherwise, let's just get straight into today's business. So in lesson number 1, the question that you were given out, there was, in the case of rolling a die, what is the probability of getting an even number? And when you've been given such a question, the first thing that you need to ask yourself is, what type of a die is this? They haven't stated that it's biased. So if it's not biased, it means it is the normal die that we all know, which has got 6 sides. That is number 1 all the way to number 6. So as you see me writing down there, it means that the sample space of this normal die is going to be having all the numbers from 1 to 6. But the event in this particular question is, what is the probability of getting an even number? So you ask yourself, what are even numbers? Even numbers are numbers that are divisible by 2 and they do not leave a remainder. Meaning to say that in this case, you're going to be having a 2, a 4, and a 6. These are the even numbers that we have. Then according to your set theory, we know that your n bracket s, it means I am individually counting the elements that are in my sample space. That is where that 6 is coming from. And my n bracket e, it means I'm also doing the same thing, the number of elements that are in the even number set, that is equal to 3. And according to axiom 1 that is written there at the top, you need to know that whenever we are denoting the number of outcomes in an event, for example, E, it means that is going to come out to be the probability of that event divided by the number of outcomes in an event space divided by the sample space. So if I can take that again, the probability of an event, which is going to be denoted by PE, it is defined as the number of outcomes in an event space divided by the number of outcomes in a sample space. So that is the reason why you see that we defined what our event is in this case, which was me getting an even number when I have rolled a die, and we said there are 3 even numbers there divided by the number or the outcomes in a sample space, which is giving me a 6. So from your axiom 1, that is the first thing that you need to know. And also, when you're going to be giving out your answers in probability, kindly note that they have to be put as a fraction in its lowest terms. So moving along on to axiom 2, 3, and 4, note that those 3 are all related or interlinked. So when it comes to events, you need to know that there are some events that are impossible to occur. Others, it's very certain that they will occur. And then there are some that can always lie in between the two. For example, today it's a bit cloudy outside, so it is very certain that it is going to rain. The moment I say that, it means the probability of it raining today is certain, meaning it's equal to 1. Then you'll be like, what is the probability of it ever snoring in Eswatini? Well, it is never so. It has never snored. So it's almost a bit on the impossible end. So we can say the probability of that event ever occurring, it's going to be equal to 0. So events that have a probability of them being 0, it means it's impossible for them to occur. And then those that where it's very certain that they're going to occur, it's going to be equal to 1. Then there are some events that can always range between our 0 and 1. That is to say that the probability of any event is therefore a number that satisfies that inequality. So what that simply means is we can never have a negative probability, or can we ever have a probability that is greater than 1? So that is to say that when you're now doing your own calculations later on, please do mark for yourself. 1, the answer can never be negative. 2, the answer can never be greater than 1. It should always satisfy that inequality that you've been given there. Okay, right to the last hurdle. So we are now saying that in our question 1, we had said that what is the probability of getting not an even number? So not that in question number 1, which was your A, it was saying what is the probability of getting an even number. And because of the definitions that we did state on our lesson 1, we did say that make a supposition that me getting an even number, the event of me doing that, it's going to be complementary to me not getting an even number. So what that means is we are just going to make use of the solution that we actually got in question A and use the definition that is in Axiom 5 to say that the probability of an event E occurring, which is denoted by my PRE, and the probability of an event not occurring, which is going to be denoted by my PR-E. If I add the 2, I am meant to get a 1. So you just make use of that equation, put what you are trying to find on the unknown side, and then you'll solve it such that the probability of me getting an even number, it's going to be half, and the probability of me not getting an even number, it's also going to be a half. A half plus another half, I will get a 1. Well, now we know all the 5 axioms of probability, and we have managed to tackle the lesson 1's experimental problem. But I think we left out section B and section D, which was B, what is the probability of getting a prime number? What is a prime number by definition? It is a number that is divisible by 1 and itself only, which means the prime numbers that you are going to probably get when you're rolling a die, it's going to be a 2, a 3, and a 5. So it means that is equal to 3 divided by 6, and it comes down to it being half. That's the answer that you're meant to get there. And then for your D, the number, what is the probability of getting a number greater than 4? Number greater than 4, it can only be a 5 and a 6. That is 2 numbers, 2 divided by 6. In its lowest terms, you're getting a third. So that is what you were meant to find from the other 2 questions. But then in today's exercise, I think it will just take you 10 minutes to calculate question 1 and question 2. I think in our next lesson, we are going to do a tutorial only for question 1, and I will leave you to do question 2 on your own. Therefore, as a summary of today's class, what we need to know is the probability of an event is a real number greater or equal to 0. That's a real event. And recap 2, the probability that at least one of the possible outcomes of a process, such as rolling a die, it has to be a 1. That speaks to me saying that the probability of any event ever occurring should always lie between your 0 and your 1. And then lastly, if 2 events A and B are mutually exclusive, then the probability of either A or B occurring, you are simply going to be adding the probability of event A occurring plus the probability of B occurring. These are mutually exclusive events. But we will also tackle a question that is going to explain in detail your recap number 3. So that's just about it for today. So like always, if you do have questions, please just do type them down in the comment section and try as much as you can to answer the 2 questions that I had put down there. Then our next session is going to be a tutorial specifically for question number 1. Thank you. We'll see each other.